So back in November, I started playing with AI agents. I was trying to build a local, offline, legal AI chatbot, essentially. Well, that didn't really pan out just because the technology got outdated as soon as I finished building the thing. I did learn a whole lot about how AI agents worked, and I realized I had something that didn't really exist yet on the market, just because the mainstream was trying to go, and is still trying to go in a completely different direction. You see, most AI tools think that parallel agents and as many agents working as possible and agent swarms is the future. And that might be the future. But right now, I don't think agent swarms is the most efficient way to get what you want. Single agent execution through sequential orchestration being done through a determinative framework is far more efficient, far more reliable, and far more autonomous. The Ralph Wiggum loop, which is a bash script that essentially just tells the AI agent, hey, keep going as soon as it's done with its turn, as soon as it quits, and it'll keep going until it's decided it's finished, is a very, very elementary version of what I've produced. I essentially took the Ralph loop, a bash script, and turned it into an entire pipeline. I've been hearing a lot of problems of the different walls that AI agents are hitting and the different problems that they keep encountering and context issues and all of these sorts of things. And it's so funny to me because these are all problems that I had already encountered and I've fixed with this system. Like AI agents not knowing about your code base, I created a dedicated feature so that AI agents are able to figure out what your code base is. And I implemented that as part of the pipeline. AI agents don't do evals and don't do tests when they're implementing things. I designed the system so that it has to do tests, and that if it doesn't pass the tests, it doesn't pass the feature that you just tried to implement. AI agent goes on the fritz and doesn't do what it's supposed to. I added a step in the pipeline so that another agent gets called and troubleshoots and figures out the problem so that it can continue without having to completely stop it what it's doing and request a human in the loop. Now, because of the level of complexity that this pipeline introduces, it's actually not super good for developing single features or developing very, very small projects. But when it comes to very large projects or operating within pre-existing code bases, which already have a lot of complexity in them, it's pretty remarkable how well it works. And if there's a problem, if there's an issue and you're like, okay, where did this go off the rails? I have everything automatically logged so you can go back and figure out exactly what went wrong in a matter of minutes. If you say, oh, I don't like this feature, when did it get implemented? I don't like this particular way you interpreted the task. It takes less than a few minutes to go and diagnose what happened. It's pretty incredible what it's capable of doing. Now, obviously, it's not as fast as agent swarms, but it's so much more token efficient, and you don't get agents interfering with each other and destroying each other's work. You don't have to worry about orchestrating and merging parallel Git work trees just to have different features get built all simultaneously. Because the thing is, every single time you want to step in for some reason, every single time there's an issue that requires a human in the loop, if that's the sort of thing, or rather, if it's something that requires a human and it's the same sort of issue that happens frequently, that happens more often than not, that step can just turn into its own automated step. It doesn't have to be a human that's handling it necessarily if it's a human that's doing the same thing over and over again. And so all you have to do is identify what that failure mode is, figure out how to determinatively identify that failure mode, and then add an extra step that solves that problem when it gets encountered. And it might not be able to solve it all the time, but if you're able to reduce the amount of times that you need a human in the loop by 90% with the addition of this extra step for this particular failure mode, I don't see why you wouldn't want to do that. Autonomy, in this case, is just figuring out how to determinatively identify as many of these failure modes to then be able to, again, determinatively route agents, dedicated agents, that are able to and are designed to solve that specific failure mode. And if you have enough routing logic, you're going to be able to automate pretty much every single step that normally requires a human in the loop. Now, if it's seriously a novel issue, well, I mean, I also designed a step for that, but if it's really, truly, legitimately a novel problem that the system just isn't capable of solving for one reason or another, then yeah, stop the autonomy and request a human in the loop. But that's so often not the case. It's so often that you don't need a human in the loop for all of these problems and you just need a specialist. And so that's what I designed my framework around. I designed it around that philosophy. Every single step, every single issue, every single failure mode that happens more than once or twice, that can be automated. And I'm going to prove it.